Today we're going to take a look at volume versus capacity. Now I know I wrote it in a way that was like, versus, like a wrestling match. Feels kind of extreme. Not so extreme. Okay. But we'll still have some fun. So, first we're going to take a look at capacity. Capacity is the amount of stuff that something can hold. So you can think about it as, like with the root words, kappa or capability. How much is an object or a container able to hold? Okay? So if you look at these containers or glasses, which one do you think has the greatest capacity? In other words, which one do you think can hold the most, contain the most? In this case, purple dyed water. Okay. Let's see. We have about 500 milliliters. Let's see. This one holds over 500 milliliters. Okay. I'm gonna do my most careful pour. Okay. I don't know why I'm holding this. Pretend like I never lifted that up. This one doesn't even hold close to 500. Oh goodness, I'm kind of worried about dumping this one back. Make a little mess, it's okay. Ooh, but I didn't. Perfect. That's what I'm doing on the hardwood floor. And then let's check this one. Okay, still a lot left over in this one. All right, from this, we can conclude that this container has the greatest capacity. It can hold the most in it. Now we're gonna take a look at volume. Volume is the amount of space an object takes up. Let's look at this cube. Say we wanted to figure out the volume of this cube, or how much space this object takes up. What could we do to figure out how much space this takes up? Well, we always want to start with what we know, okay? If we look at just the surface, if we could slice it off, we would have this, okay? A plane. It's pretty much supposed to be two-dimensional, okay? It doesn't have that height to it, a 3D height, okay? We're gonna pretend this is completely 2D. And if we're looking at this in a 2D lens, we know that this has a length and a width. And if you remember from our area formula, length times width gives us area. That would be the area of just this 2D plane. However, if you stack them up, you would end up getting the cube. So, in order to find volume, volume looks at the air, the space of a 3D object rather than just a 2D plane. So we're gonna have to calculate length times width times height. Okay? So, what is our length? Oops, sorry, I'll write down the formula. Volume equals length times width times height. Length, width, height, or height. All right, and our length would be 1, 2, 3, 4, 5, 6. 6 units times, what is our width? 1, 2, 3, 4, 5, 6. Also 6 happens to be in this case 6 units times our height. So now we're going up. 1, 2, 3, 4, 5, 6. Times 6 units. So volume equals length times width times height. And for this particular cube, we have a length of 6 units, a width of 6 units, and a height, it's hard for me to do with one finger, height of 6 units. We need to do 6 times 6 times 6. How do we do that? Well, start with what you know. Always start with what you know. What is 6 times 6? We know that 6 times 6 equals 36. Okay. And then 36 times 6, we need to figure out. 36, I like to write it up and down, vertical, excuse me, because my brain just works better when I put my numbers vertically. So 36 times 6. 6 times 6, I already know is 36. Leave the 6, carry the 3. 6 times 3 is 18. And 3, 21. 1 and 2. Okay. Giving me 216, which means 6 times 6 times 6 equals 216. But we can't forget our units. So, let me rewrite this. Volume equals 216 units. And if you remember from, sorry, I have to lay this down. If you remember from area formula, length times width end up creating units squared. And with a shape like this, a square, it's pretty easy to see because it is a square, right? Same thing with this beautiful object. This is a cube. So this is called cubed because we're looking at 3 dimensions. Oh, can you tell it's a 3? So instead of to the second power, it's to the third power, because it's units cubed, because we're looking at 3 dimensions this time, not just 2. We included height this time, which gives us cubed, okay? So for your follow-up, I'll give you a series of, I'll show you an object, and you'll have to calculate the volume using the formula length times width times height. Okay, you'll get into it deeper as you go along in your academic career, but this is just the starter piece. To explore capacity, you're gonna do it just like I did. Okay, I'll explain the directions again in the document, but really you're just gonna get out 3 objects or 3 containers. You could do more, but at least 3. Make a hypothesis of which one is going to have the greatest capacity. Fill them up and figure out which one has the greatest capacity.